Hello, my name is Dan Chuan, and today's lesson will be using fundamental trig identities to simplify expression. Let's go ahead and go to the first example. First, I want to apologize if my handwriting is hard to see because I'm writing it on a mouse. But yeah, here we go. So the first identities that we got to remember, and it will come in handy later on, is the Pythagorean theorem, in which we have, I'll do it in red right here. We have sine square of theta plus cosine square of theta is equal to 1. And from this parent identities, that's what I say, you can just play around with it and move it around. So you also have if you move cosine over to the right side, you also have sine square of theta equal to 1 minus cosine square of theta. And if you move sine square theta around to the right side, you also have cosine square of theta equal to 1 minus sine square of theta. Just note that this will come in handy later on. And okay, let's go back to our example. I encourage you to go ahead and pause this video for about 30 seconds and try to figure it out on your own. Okay, so in this one, I'll use the second identities so that to substitute into the expression. Right here we have 1 minus cosine theta, and which is equal to sine of theta square. So I'll go ahead and write this one as sine of theta square. And the rest of the expression is sine square of theta. And the results for this one is just gonna be 2 sine square of theta, because we have sine square of theta plus sine square of theta is going to be 2 sine square of theta. Let's go ahead and go to the second example I have for you. We'll have secant of theta times cotangent of theta. In this expression, and for the second example, I'll give you a hint. You can use the quotient identities and the reciprocal identities to simplify this expression. So go ahead and pause this video and try to work it on your own. Okay, so in this expression, you might want to think about first of all, the reciprocal identities, in which it says secant of theta is equal to 1 over cosine of theta, and cosecant square of theta is equal to 1 over sine of theta. That's the reciprocal identities. And also, you might want to think about the quotient identities, in which it says tangent of theta equal to sine of theta over cosine of theta. And the quotient identity also indicates cotangent of theta is equal to cosine of theta over sine of theta. So in this expression, we'll use the first one and the fourth one and the fourth one to simplify this expression. So the first part of it is going to be 1 over cosine of theta. And the second part of it is going to be cosine of theta over sine of theta. Two of them times together, multiplied by together. And right here we have cosine and cosine, so you just go ahead and cancel it because it's all going to be 1. And which left us with 1 over sine of theta. And you might think that, oh, we're already done, but we're not. Think of it as, oh, we can still simplify this. You might want to try to go for the easiest, the most simplified expression as possible. So what is 1 over sine of theta? Right here we have 1 over sine of theta is equal to cosecant of theta. So the result for this expression is going to be cosecant of theta. And we're done with the second example. The key in this exercise is to remember the fundamental identities and how to apply it. Okay, and we will go ahead and proceed to the last example for today lesson. I'll have secant of theta times cotangent of theta. This expression will include, let me go ahead and try it again. I made a mistake over there. Our last example is cosecant of theta minus cosine of theta times cotangent of theta. In this last example, you will try to use every identities that we have learned so far and try to apply it into this example. So what do we have here? We have cosecant of theta. Trying to think it as, what is cosecant of theta? And as we already learned, the cosecant of theta is 1 over sine of theta, the reciprocal identity. I'll go ahead and write down sine of theta. And I'll write the second part in blue. Actually, black. Minus cosine of theta. And this part is blue. What is cotangent of theta? So cotangent of theta, it just simply is cosine of theta over sine of theta. And I'll just plug them in. There we go. So if you're trying to solve this expression, we also have the denominator as sine of theta, and the top is 1 minus cosine times cosine of theta is going to be cosine square of theta. See, the key to take right here is to remember what identity to use and how to apply it into your expression. And at this point, you might think that, oh, we're already done. Looks so easy, but wait, we're not done yet. We still have one more step to go, and this will go back to the Pythagorean theorem, in which we have 1 minus cosine square of theta. What is 1 minus cosine square of theta? Well, I'll say to you, 1 minus cosine square of theta is equal to sine square of theta by Pythagorean theorem. If you don't remember this, or you might wonder where did I get this, you can go ahead and go back to the first example in this video to see how I prove the Pythagorean theorem. So 1 minus cosine square of theta is equal to sine square of theta. And over all of them over sine square of theta. And the final result will be sine square of theta over sine of theta will be sine of theta. And we are done. I encourage you to go ahead and take a screenshot of the video or um, take or pause the video before every of the example to go ahead and work on your own and later on watch how I prove it so it's easier for you to take in the lesson and understand. And that's it for the lesson today. Thank you.